Hello and welcome to this learning video. In this learning video, we are going to start with a very important topic named as unit impulse function or Dirac delta function, okay, which has its own importance, right? So let us start with this function. So let f of t is equal to 1 by epsilon in the interval a less than equal to t less than equal to a plus 2 pi, and its value is 0 other than this interval. Okay, if you can see the graph, this function has values only in the interval a to a plus epsilon. Okay, and there is no value apart from this interval, means other than this interval it has value 0. Okay, so this is what we have written, and this is the graphical representation of this function. Now when epsilon tends to 0, so 1 by 0 is infinity, so f of t tends to infinity at t is equal to a. Okay, because if this tends to 0, this becomes just a, so epsilon tends to 0, f of t will tends to infinity at t equal to a, and otherwise it is f of t is 0. Okay, as you can see from the graph itself. Now f of t is 0 with the property, and we have the property integration from 0 to infinity f of t dt is 1 for all values of epsilon. Okay, now the limiting value of this f of t when epsilon tends to 0 is called unit impulse, or Dirac delta function at t equal to 0, and this Dirac delta problem or the function is given by delta t minus a. That is the notation. So we can define delta t minus a. What is this Dirac delta function? It is the limiting value of the function f of t, defined like this. Okay, so delta t minus a is limit epsilon tends to 0 f of t, where f of t is this. Okay, now this is the Dirac delta function. Now when you want to take the Laplace transform of this, what it should be? The Laplace transform of delta t minus a is e to the power minus as. Okay, and the inverse Laplace transform of e to the power minus a is delta t minus a. Okay, now let us see now the unit impulse function. The unit impulse function at t is equal to 0. So what we need to do is we need to substitute a is equal to 0 in this. So the unit impulse function at a equal to 0 is given by delta t epsilon tends to 0 f of t, where what is my f of t? F of t is 1 by epsilon, a is 0, so t line from 0 to epsilon. And what is Laplace transform of this delta t? Is 1. Okay, and inverse Laplace transform of 1 is delta t. This result is very important, because when we see the application part of Laplace transform to solve integral equation or differential equation or integral differential equation, okay, in such applications we make use of this result most of the time. Okay, so this is very important as far as the applications are concerned. Now after this thing we have the another function which is periodic function. So periodic function is very well known to you. So can anyone define what is periodic function? Yes, very simple definition is there. You can define in terms of physics also. Okay, so let me define this. Next is periodic function. Okay, so what is periodic function? A function which repeats after an equal interval of time. That is the physical definition of this periodic function. If you talk about the mathematical definition, so what you can say, for t greater than 0, f of t is equal to f of t plus t, f of t plus t. Then this function f of t is called periodic, with period t. Okay, so it should be greater than 0, that you have to taken care of with period t. And do you know the examples of periodic functions? The very simple periodic functions are sine, cosine. Sine function and cos function are the periodic function with period 2 pi. If you talk about tan, it is a periodic function with period pi. Okay, and so on. There are so many examples of periodic functions we have. If you want, I can write, for example, sine t, cos t are periodic function with period 2 pi. Okay, so we have to take the least value. Okay, so you please take this remark, that the least value of t for which f of t is equal to t plus 2 pi, then the function is said to be periodic. Because you might you know that sine of x plus 2 pi, sine of x plus 4 pi, sine of x plus 6 pi all are periodic, but what is the least value? 2 pi. Okay, so least value of t. Okay, now next thing is the periodic function of the Laplace transform of the periodic function. So I am just quoting that result. The Laplace transform of periodic function. So what is Laplace transform of periodic function with period 2 pi, with period t, So suppose you have a function, periodic function, say f of t with period t, then what is Laplace transform of that function? Laplace transform of that function f of t is equal to 1 upon 1 minus e to the power minus st, okay, into integration 0 to t f of u du into e to the power minus su. So that is the Laplace transform of the periodic function f of t with period t. Okay, we'll make use of this result to get the Laplace transform of periodic function. Okay, so let us take an example. We take simple example of this Laplace transform of this periodic function. Example, find Laplace transform of mod of sine t. Laplace transform of mod of sine t. Only this thing is given to you, so you must know the periodicity of sine function and modulus of sine function, because there is a difference in the period of sine function and sine mod of sine t function. Okay, so let me write down first of all the solution. So solution will follow like, let f of t is equal to mod of sine t. Okay, and this function is periodic with period pi. This function is periodic with period pi. If you really want to see whether really this function is periodic or not, you can go for the graph of this function mod of sine t. Okay, so if this is t and this is say f of t, okay, so what it should be, because it is mod, so all the value would be plus. Okay, so say this is to be 0, so pi, right, and then one crest and one trough would be here, but this will be taking negative values, but we have the modulus of that, so this function would be like this. I'm not good at drawing this, and then this, and so on. Okay, what is this values? These values are pi by 2, 3 pi by 2, 5 pi by 2, okay, and all these values are 1, this is 1. Okay, so you can see this function, this is the graph of the function mod of sine t. Okay, and no need to draw this thing in the examination, because this is for the extra knowledge. Okay, so this is about this Laplace transform of mod of sine t. Now once you know that this is my periodic function with period pi, so you can directly write down the Laplace transform. What is it? Laplace transform of, what should I write? Laplace transform of mod of sine t is equal to 1 upon 1 minus e to the power minus s pi integration 0 to pi e to the power minus s pi s u into sine u du. Why I am not taking the mod? Because in the interval 0 to pi all the values of sine would be plus. Mod of sine t will be sine t. Okay, now you just apply the integration of it. So this is very simple thing. So you can easily write down the solution of this one. So this is say 1 upon 1 minus e to the power minus s pi, and then apply here the integration of this. So I am using the special formula of integration to this, 1 upon s square plus 1 into e to the power minus su in bracket, this is minus s into sine u minus, what is derivative of sine u? Cos u, and then you have to apply here bracket close 0 to pi. Okay, so this is like 1 upon 1 minus e to the power minus s pi into s square plus 1, right? Apply upper limit minus lower limit to this. So when you apply the upper limit, it would be e to the power minus pi s, and sine pi is 0, so minus s into sine pi is 0, and what is cos pi? Cos pi is minus 1. This is just the upper limit minus lower limit. E to the power 0 is 1 into minus s into sine 0 is 0, cos 0 is 1. Okay, so this is it. So at last I am going to write this as Laplace transform of mod of sine t is equal to, this is 1 upon 1 minus e to the power minus s pi into s square plus 1. Here it should be, what is it? Minus minus plus, and here this minus minus plus. So what is it? Okay, e to the power minus pi s, this minus minus plus, minus, what is it? 1 into 1, so this is plus 1. So 1 plus e to the power minus pi s upon 1 minus e to the power minus s pi into s square plus 1. That is the required Laplace transform for this periodic function whose period is pi. Okay, so thank you for watching this learning video, and I hope the things that I have discussed in this learning video are clear to you. So thank you and happy learning.